Hello and welcome to an introduction of deep foundations. We've all seen structures similar to the one next to me on the screen. These engineering marvels seem to exist in conditions that would not be conducive to buildings. The secret to these structures lies within their deep foundation system. There are many examples in the world where great cities are built upon deep foundations, such as my hometown, the Big Apple, New York City, London, Sydney, and Abu Dhabi. In this module, we are going to introduce you to construction piles and caissons, their applications, and methodology for quantifying this construction technique. Construction piles. A pile is a vertical structural element of deep foundation driven deep into the ground at the building site. Here in New York, although the ground type is quite favorable, mainly being rock, deep piles are required to drill into the rock to structurally allow the buildings to stand, many of which are skyscrapers. A pile is usually the term used to refer to a solid piece of material, such as steel pipe, H-columns, or a precast section that is driven into the ground with a large piece of equipment or machinery. Construction caissons. A caisson is a cast-in-place concrete system where a hole is drilled into the ground. The bit is then removed and a cage of steel rebar is then dropped into the hole carefully by skilled machinery. Concrete is then poured into the shaft to form a solid concrete foundation. Depending on the size of the project, you may have several pile foundations, sometimes hundreds or even thousands. The purpose of a construction pile or caisson is to transfer the load of the structure down to the solid foundation that can be found at variable locations below the Earth's surface, preferably rock or a similar material. Typical reasons for utilizing construction piles include poor soil conditions, such as sand, or for construction over water. Alternatively, deep pile foundations paved the way for allowing skyscrapers and taller buildings within the construction industry. Deep foundation equipment. Depicted here is an example of a device used in pile driving. This is a diesel high-impact hammer specifically designed to push structural members deep into the soil and then later into bedrock. As for caissons, many of these units will be equipped with a large drill or auger bit that is used to displace and extract soil to make room for the rebar and concrete pours. Typical operation of a deep foundation system will consist of topsoil, the poor soil conditions, embedded above the favorable soil conditions. The piece of equipment will be brought into place and will hammer down into the earth a large structural member. In the case of a construction pile, all the way down into the bedrock. In the case of a caisson, a similar apparatus will be used to drill down into the earth. Later, a rebar system will be carefully placed into the earth, down to the bedrock foundation, and concrete will be poured to form a solid structural member. So, moving on to caisson and pile takeoff. The typical unit of measurement will be linear feet. That calculation is quantified by linear length. And one thing you must remember is that reading the geotechnical reports will give you details of the soil composition, which can later aid in the estimation of time. Here you will find a typical plan and elevation of a deep foundation system. This system belongs to an interstate highway in the United States. Indicated on these plans is a 36-inch diameter shaft that will need to be drilled for a deep foundation system. This plan shows the bridge foundation plan. As you can see, the deep foundation system has indicated lengths that should be driven into the earth. Each of the grids on the left indicate a vertical distance of 20 feet. Quantifying that length arrives you at roughly 80 linear feet. You must always remember that all plans are project specific and not all projects have the same notes and indications. Be sure to utilize your professional network and submit RFIs for any inconsistencies. So in the case of the interstate highway, the plans are indicating a 36-inch or 3-foot diameter drilled shaft. Additionally, the plans are indicating that the shaft must be drilled down at a minimum of 80 linear feet. Thus, you can quantify the volume of the drilled shaft by solving for pi times the radius squared times height. As we discussed earlier, the volume of a cylinder is calculated by pi times the radius squared times height. With our example, we'd be multiplying 3.14 times 1.5 feet squared times a height of 80 feet. Solving for cubic yardage, we know that the volume of each individual caisson will be 21 cubic yards. Here you will see the various takeoff line items that can be quantified from the details we reviewed earlier. Firstly, you will need to identify the equipment rental and operator costs for the machinery required to perform the work. Secondly, we can quantify one of the caissons based on the details at 36 inches in diameter at roughly 80 linear feet deep. Next, we've identified that a number 5 rebar cage will need to be placed within the steel pipe. Finally, we can quantify that roughly 21 cubic yards of concrete will need to be poured within the caisson in order to complete the operation. In summation, pile foundations have directed the modern construction world into taller, record-breaking skyscrapers. Pile foundations have assisted in building in locations where historically it was assumed the land type did not allow for any building type possible, let alone tall buildings. Piles are measured by linear lengths and are driven into the ground by large machinery. We hope that you enjoyed this module. Thank you, and see you all again soon.